Contrails. Contrails are the result of water vapour crystallising around aircraft exhaust, and as such they represent an artificial cloud that exists high up in the atmosphere. This quote from aerospaceweb.org reads, "Contrails typically form because of the interaction of a vehicle's exhaust with the ambient air at altitude. The air at high altitudes is generally cold and dry, while the exhaust from aircraft engines is hot and humid. As these fluids mix, the water vapour of the exhaust freezes in the cold ambient air to form ice crystals, and they're known as contrails." So, contrail formation. The aircraft burns fuel, which are hydrocarbons, and produces heat, plus water vapour, plus condensation nuclei in the form of soot, sulphur, etc. The study of condensation nuclei is the subject of a cloud microphysics subject you'll do later, but sufficient to say for the moment that condensation nuclei make it much easier for liquid water drops and ice crystals to form. The exhaust and the environmental air are mixed isobarically, that is, at constant pressure. And so two unsaturated air masses may be mixed together to produce a saturated air mass. The relative humidity of the resulting mixture of these two air masses depends upon the temperature of the exhaust, and so a higher temperature will produce a lower relative humidity, the amount of water vapour that's present in the exhaust, and the temperature and the dew point temperature of the environment. Once the air is saturated, excess water vapour produces droplets which freeze and grow, forming the contrails. For a given pressure and temperature and water content of aircraft exhaust that can determine the temperature at which the contrail forms, that is, the highest environmental temperature at which contrails may form. And different engine types have different corresponding values of TCF. Contrails persist depending upon the atmospheric moisture. The drier their atmosphere is, the more quickly you'll get dissipation. And wind strengths. So under weaker wind conditions, it'll persist longer. Stronger wind conditions will mix things up and result in dissipation. In military operations, they usually want to avoid forming contrails, so if you're ever posted to a military installation, they'll be particularly interested in terms of their forecast briefing. For example, here's a military R4 for Williamtown in New South Wales, and you can see lots of different information in terms of meteorology, but here we see possible contrails above flight level 290, which is 29,000 feet, and probable above 35,000 feet. The various techniques for forecasting contrails are best left to the operational environment.